intended to implement anything, but it is true that heaps are usually done in arrays, so that's fine. The two main ways that heaps are different from binary search trees, or the two simplest ways, are the shape and the manner in which they're structured in terms of their order. So heaps are complete binary trees, and heaps have a looser ordering than BSTs, in that the left and right children are not distinct from each other. The purpose of a sentinel node, what I wanted to see with this was, like, why would we want to use them? What benefit do we get from them? And a lot of people put things that are commonly true but not actually real benefits, like accessing certain parts of the list. Well, I mean, you can do that with pointers, right? You can have a pointer to the beginning and end of a list. The main utility of a sentinel node, the purpose of a sentinel node, is it allows us, for some linked lists, for some situations, to have algorithms that are much simpler. It removes special cases from code. Now, it's not the case that a sentinel node is always going to do this. For example, if you use like stack, there's no point in having a sentinel node in stack because there are no special cases to take care of. So it provides you with no benefit whatsoever. If you go back and look at how we implemented stack, you should see that you don't have to do anything special when the stack is empty versus when there's one item in it or multiple items in it. The same algorithm is going to work in all circumstances, so it doesn't benefit you. But for list 3, having 2 sentinel nodes here is a huge benefit, because when you go to add an item, well, there's already a linked list with at least 2 nodes in it. And the algorithm is going to be exactly the same. If you're adding the first item, it's going to be the same if the left string is empty, it's going to be the same if the right string is empty. If you're in the middle of an enormous list, it'll be the same. So you don't have to write special cases for all those situations, because there are always at least those 2 nodes in the linked list. So that's what it provides us with. Sentinel nodes allow us to generalize our algorithms, but they allow us to remove special cases when they're used properly. For 1.1, something some people put which is not true is that they said, like, well, heaps can have duplicates. Yeah, binary search trees can have duplicates too. That's not different. Now, the project you did, you worked with set, and they promised you that the comparator was using a linear order, so it didn't come up in the project, because if the comparator is a linear order and sets can't have duplicates, you won't have equivalent testing items. But all my slides went over this and we talked about it in class. And there's nothing that prevents a binary search tree from having duplicates. Which is why we defined the binary search tree property the way we did. Let's see if there's something else I want to say about 1.2 that isn't the case. They don't necessarily make things faster. In fact, like in list 2A, the addition of a sentinel node actually made something run slower, because we were no longer able to access the end of the list in constant time, adding a second sentinel node afterwards because it was a single linked list. So it's not really performance either. It's although in some cases it can help performance a teeny bit because you don't have like statements where you're checking for the special cases. The main benefit is the code is simpler, easier to write, easier to read, easier to test. 1.3, tokenize, parse, and generate object code. Those are the 3 steps. Compiling is not a step of compiling, but I appreciated the recursion. It did not pan out well for you in points, but it was fun. If you call any method and pass a pointer to an object, well, after that, you know it's not null because it's still going to be pointing to that object. Why is it still going to be pointing to that object? The reason why is everything in Java is passed by copy. The method is working with a copy of that pointer. it may be able to change the object by following its copy of the pointer, but it can't change the pointer. There's always one level you can't change with parameter passing in Java because it's always passed by copy. So just the word copy somewhere was sufficient for that one. You know, that's the idea, and it's an important idea. Like the only things that you'll see change at all in terms of parameters that you pass is mutable pointers. If you pass a pointer to a mutable object, the object that pointer points to might change, but the pointer itself can't change. There's always one level you can't change because it's passed by copy or passed by value. It's a reference that's passed by copy. It's not passed by reference. If it were passed by reference, you would be able to change it. Which the only things in Java that pass by reference are the accessor operator for arrays. Gives you access by reference, so it'll actually change the thing in the array and change what the accessor returns. And when you use a for each with arrays, it does the same thing. 1.5, yes, you can do an in-order walk through the tree. The structure of a binary search tree is such that everything on the left is less than in the ordering for root. Everything on the right is greater than or equal to. So if you recurse left, then you can handle the root. Then you recurse right, you're going to touch all the items in sorted order in linear time. Binary search trees are completely sorted. They're already totally sorted. So an in-order walk through the tree will hit all the items in sorted order, even if you don't know what that order is. Some people said, you know, I try and figure out the order by comparing the items and try and see what happened. And I mean, you can try to do that, but sometimes, like, I mean, you may not even be able to compare the items because, like, what if it's like T, right? If you don't even know what the object type is, well, you know, you can't compare them. You certainly can't compare them if you don't have access to the order property, which I mentioned. But like, you know, I can hand you a binary tree of T and you can print out the items in sorted order. Even though you don't know what T is. And again, that's because the structure of the tree holds that order. It's totally sorted. And it doesn't even matter if it's like a long skinny tree or a well-balanced binary tree. You'll still hit all the items in linear time. Okay. If an instance method doesn't mention a parameter mode for this, it's just like if an instance method or any method doesn't list a parameter mode for any parameter, it restores by default. So a lot of people were very confused on this, which kind of surprised me. Maybe they didn't know what parameter modes were. But you know, if we don't say what happens to a parameter, by default that means it should be restored to its original value. And that's true for this as well as for non-distinguished parameters. Next page. 1.7, I don't like. I don't like this question. By the way, a couple comments on this test in general, besides it being horrible. I am never, ever going to put this many short answer on an exam again. This was a fucking nightmare to grade. It was bad for you, too. Like, the one thing that makes this exam, I don't think, as good of an exam as I would like it to be. It's still good. Like, I still, the distribution is still decent, but the main problem is people spent so much time on the short answer, there was time crunch on the other part of the exam, which is not what I want. You know, I don't want this to be a race. I want to be able to see what you know in depth. So I don't want speed tests, I want power tests. But in terms of grading, it was also a nightmare. So I mean, at least I suffered too, I guess. I went through 3 red pens grading this. And the problem is, like, when I'm grading a short answer, I have to explain why I took off points. I can't just like take off points because it could be anything, right? So even though I don't have to put the answer down, I've got to say, well, here's what was wrong, and it's really fucking complicated in some of these. Well, 1.7 I think is the worst question on the exam. I think all the other questions are good. This is the only one I don't like. And the reason I don't like this is there are so many different things you could put down in describing heap sort. Heap sort is well known for being a 2-part algorithm because there are 2 distinct steps, both of which run in linear rhythmic time. The first step is build the heap. So if you got everything but build the heap, then it was worth 3 points. If the only thing you put was build the heap, I gave you 2 points. But the first thing you have to do is build the heap. And once you have a heap built, The second step is you repeatedly remove the root, which is the minimal element, and then fix the tree. So first step is build the heap. Second step is repeatedly remove the minimal item at the root and fix the tree. Some people just described like how Sifri down works, and I think that was the most common answer. It's like, well, here's how Sifri down works, but I want to know how does this actually sort things, basically. So yeah, I don't like that one, but most people got some partial credit on it at least. 1.8, a lot of people got half credit on this because they described the correspondence diagram, the one with two ovals, but they didn't explain like what the other two ovals are for in the commutative diagram. So there's two things here. The correspondence part is the relationship between concrete and abstract. So it's how the concrete corresponds to the abstract state. So, saying like the correspondence of an object or concrete and abstract, I mean, that was fine for that part of it. And the other part of it is it's before and after a method call. So it's showing you what changes before and after a method call in the concrete and abstract states for some object. So that is 1.8. Any questions on any of this so far? Questions so far? Okay. 1.9. So it is true that using double equal or not equal operators on a reference type is comparing the pointers. It's not comparing the values of the objects. However, enums are special. The reason enums are special is every enum object is different by definition. Right? All enum objects have to have different names, and they're identified by these names. So by definition, it doesn't even matter if they have like the same fields if you decided to give them fields. Usually you don't even give them fields. By definition, every enum object is different. So comparing the pointer does compare the object. The only way for two enum objects to be the same is if it's the same object. So if two pointers are equal, then the enum value is equal. If two pointers are not equal, the enum value is not equal. And the pointers have fixed locations to facilitate that. So for 1.10, any of these symbols work. I expected these four here, because these are the ones I talked about the most, that appear in pretty much all of the ones we do. But we did use parenthesis in some of the ones in the slides, and the official ones do use this. I don't think anyone gave me square brackets. Some people give me angle brackets, which wasn't right. We never used those as metagrammar. But these are technically used in the official BL CF sheet. And some people put, and I realize they're correct, ellipses if you have three dots in a row, because on the one I did, I used ellipses, and I'm definitely using it there as metagrammar. So that also counts. So if you had four of those and you didn't also put something that wasn't metagrammar, then you got to put that. Okay. Page 4. The block and while case here will be identical to 5 labs you've done. You're really just recursing on the children in both cases. So for block, for I equals 0 to length of block minus 1, statement child equals this dot removed from block I, child dot replace bad call remove all context, this add to block I child. And for the while case, statement block equals this dot new instance, condition C or condition con equals this dot disassemble while block, block dot replace bad call and call context, this dot assemble while con block. The call case is right here. String call equals this disassemble call. So you have to take the call apart to find out what the call string is. And what you want to do is, if that call string is not in the context and it's not a primitive instruction, then you want to change it to whatever new call is. So what we do is you can just have one big conditional is the easiest way to do it. And you can either do like, because of De Morgan's law, you can either do something like if not call equals move and not call equals turn left and, or you can do if a big not over everything. If it's not the case that call equals move or, call equals turn left or, and here I just put etc. I mean, that's fine. Once I see you have 2 of these down, I realize that you're going for all 5 of them, so you don't have to like write all of them out if you don't need to. Or context dot contains call, right? Because we don't want to do it if context contains call either, right? So if those are not the case, then call equals new call, and then we reassemble call. Any questions on question 2? Anything on question 2? Question 3, I was pretty sure this was the hardest question on the exam. A surprising number of people got this right. But here is, by which I mean any people. But several people did get it right. So here's the idea. You want to write replace bad call for a program. And to do that, you need to call it on all of the blocks in the context and also on the body. So calling it on the body is not a problem, right? Keep in mind you have to pass the context to the statement that you're calling it on. The problem is you can't pass the context to the instruction bodies as you're going through the context. The reason why is, well, and you got full credit for this as long as you realized there's going to be a problem when you try to call it on the instructions in the context, because you can't pass the context to it. And the reason why you can't is you can't use an iterator because you're going to be changing the values, so it's not completely safe to use an iterator here. So in order to do this, you've got to pull these things out of the context, right? So the context isn't going to be in one piece when you make the call here, so you don't have a context to pass it. This was really tricky. So don't worry about this one, but that's why. Like when you're iterating over the context, you don't have the full context to pass these statements that you did. So that's why. And why did I even write this fucking question? Well, it's because like originally I had it say, write it. And then at the last minute, I realized, oh, you can't fucking write this. So then I'm like, okay, why can't you write it? And surprisingly, some people did get it. Okay, on the next page, it should look like this. Not this arrow here. This arrow here is something I was using to describe the code over here. But some notes here. Real important note. This is a node object, this is a list 6 object. Please know the difference. Like a list 6 object is not a node. This is not a node, this thing here. That's not a node, right? Nodes are objects that have like a data field, a next field, and a previous field. This thing has 5 fields and it also has methods you can call on. So these are not the same, and if you have any pointers pointing to this thing, then you're confused because, all of these pointers are node pointers. None of them, this is the only list 6 pointer over here, is this. These need to be 1, and you should have left string is 3, right string is 8, and this between is in the middle. You can either look at the formal description in the ref invariant and abstraction function there, or you can look at the English description where it says there's no central node at the front or back of the list, but there is one in the middle between the 2 strings. And most people did read that and actually got this right. 8 points was the most common number of points on the page. On the next page, oh, and by the way, there's no null convention here. So people lost a point if they relied on these guys being null. You didn't lose any points for the diagram if you set them to be null. That was fine, because that's acceptable value. But nowhere in here does it say that those things are going to be null. So that means like you can't check to see if they're null. Like you have to check something like right length equals 1 for the special case, or you could check if this between next equals finished. That would also check it. Yep.
For the data values in these nodes, do we not need like the triangle pointing to the square?
Yeah, you don't need to. I never do that because it's too many fucking pointers. That's the problem. You can if you want to. I mean, you don't lose points for doing that, but it's a lot harder to read. It's you know, these guys are also pointers because they're T, right? So they have to be a pointer to an object. But I'm just illustrating it there as if it were directly there. Okay. So the code here, here's code that works. Node to delete equals this between next. You can abbreviate stuff on exams as long as it's unambiguous, as long as there aren't two things it can mean. So I don't know if you knew what you were talking about. I can figure it out. I'm pretty smart, and you know, you don't have to like write paragraphs for me. So node to delete equals this between next. This between next equals to delete next. You don't have to do this in all cases. You could put this just in the else case if you wanted to. The special case you have to consider is if right length equals 1, then you have to update this finish to point to this between. Because you just removed this, so finish needs to point to the central node now. Also, if right length isn't 1, then you need to take whatever this node is, because there's another node, and point it back to between. So in that case, this between next previous equals this between. If I did this after this, it would have to be this between next previous equals this between. Just like if I did this right length minus over here, this would be 0 instead of 1. Some people just put 0 here without even the deduction, and well, that violates the requires clause, right? The requires says, how did this happen? How did I end? No, this has to be another. That's impossible because the tests are all the same. There's a place where something. How was that even possible? I only printed it out once and I photocopied it. Wow, that doesn't make any sense. That's. Might indicate academic misconduct. And someone with no, that's why. Oh, thank goodness. Okay. No, when they printed it out at Auspice of Disability Services for another student, that must be what it was. They printed it out differently, and so the requires clause ended up on the wrong page. Okay. I was worried that someone like brought their own test. Like there's no way they would get a hold of this. So I mean, I just made it. Okay. Sorry. Yeah. On when ODS printed these out, like they used OpenOffice or something instead of Microsoft Word, or they used a different version of Word because Word's a piece of shit anyways, and who knows what it will do. So the requires clause ended up on page 6 instead of page 7. Okay. So that's so after this, deduct 1 from right length and then return the data. Any questions on this? All right. This was tricky. This is the correct thing. It's important that like block and call and while and if else are all caps because these are enum values. Most people get this right because like it's also the text, although there is no block keyword, which will come up in a second in VL. These the kinds and the conditions are uppercase. So the condition here, this isn't VL text. This is an enum value in Java. So this needs to be all uppercase. So that is important. Like you're getting languages confused if you have this in lowercase. You're getting VL text confused with the AST Java enum. You're really getting languages confused if you put like do or then in these guys. because like do, well, it's not part of the statement label, right? Like there's a while statement time, there's not a while do, there's certainly not while true do, that doesn't even make sense, right? These are statement labels that have like 3 different fields. Block goes to call move, while true, while has exactly 1 child, which is a block. First tricky thing here is the first thing under the while, first child is block. Well, block is not a keyword in VL, so this is a call to block. So this is the call string here. So we're literally calling a user-defined function called block. Second child is an if-else, which I'll come back to. Not an if, an if-else. This is the trickiest part on probably the whole exam. So here, we've got call and skip. Call's not a keyword in VL, right? Some people got this almost right. They did call skip, right? So they're like, oh, okay, well, then it's one big thing. But even though it's on the same line, there's a space there. So those are 2 separate identifiers. So those are 2 separate calls. There's a call to call, and then there's a call to skip. If else random has exactly 2 blocks underneath it. This block, well, there's nothing in it, so there's nothing underneath it. And this block underneath it is a call to turn right. I saw some crazy shit on this, people in all 3 sections. Some people did things that weren't trees. Some people had like a big long line of things that had calls in it, and calls can't have children. So you should understand the structure of program before the final, that would, or statement before final, and therefore a program. That would be good if you did that. Last one. So my pants keep falling off. It's a problem with losing like 20 pounds when you have no pounds to lose. Yeah, so for 6, this is the answer. You don't have to memorize VL to get this. You can determine this based on the CFG that's already there, as long as you know basic facts about VL. Identifiers have to start with a letter, so there has to be at least 1 letter, and it can be followed by any number of characters. So, like, you can have letters, numbers, and dashes, but the first one has to be a letter, so this is how you do that. Right? 1 letter followed by 0 or more characters. Most people got 1 point on this page, because if you put anything related to letter or character under ID, I gave you a point. Instruction, well, what is instruction? Well, we look, and the only place in the CFG it's referenced is in program. It comes after the program name is, and before begin. So, and there's 0 or more of them. So each instruction is going to be one of those user-defined instructions. It would have to be. And if you don't know the keyword, instruction is there. I mean, you can look at the keyword list, and there's one called instruction that we have to use, so that's got to be in there. And also there's a hint under instruction that says the 2 ID must match each other, so we know this ID thing has to appear twice. Right? So the format's going to be similar to program ID. Here, it's instruction ID is, and then a block, right, the body of the instruction, and then end ID. Now, if you put end instruction ID or instruction end ID, I give you credit. Like, I don't expect you to like memorize exactly what the format is for it. But this is how it do. Any questions on the second midterm? Questions on the second midterm? Yes?
Can we go over the questions for that?
Yeah. Again, this is one I don't really expect people to get, and there will be nothing that's hard on the final. But although, you know, your mileage may vary when it comes to hard. Some people did this right. So, I mean, maybe things will be harder for you personally. But, okay, so the issue here is we have to call replace bad call and pass it to context. Well, we can't do that on the instruction bodies in the context, because we don't have access to the context when we're doing this. The context is not going to be in one piece when I try to make the call on this. Because in order to do it, I've got to pull it out of the context first. And I have to pull it out because I can't iterate over the context altogether. That's it, basically. If you put anything that sounded like there's going to be some problem when you iterate over the context and try to call this, then I give you credit. And some people got partial credit because they sort of were on the right track. And then some people like randomly gobbled things in the hopes that perhaps they would stumble upon a word or two that would give them measurable form of success.
We'll go over how to build the heap.
Yeah. Building the heap's pretty simple. So if you wanted to describe how to build a heap, you recursively build the left subtree, recursively build the right subtree, and then set through down the root. That's literally build a heap. Like build heap left, build heap right, set through down. You have to check if left and right exist before you call build heap on, but that's it. Build heap, set through down. Yes.
Do you have any expectations for how the curve is going to go, having all these grades in?
It's going to be better than what's already on Carmen. So like on Carmen, there's already a curve, like 85 is an A, right? It will be better than that. It will have, I think I said this in the email, it'll have a stronger effect on people who have, I've been standing up and not had much time to sit down today. It will have more of a pronounced effect on people who have lower grades, but because the distribution is pretty wide, and some people are still knocking it out of the park. There's a few people doing that, and that shouldn't like affect other people. But yeah, there will be a curve that will be bigger than what's in curve. And it's a curve on the entire class, not on any specific item in the class. Yes?
Are you going to send out the distributions like you did for like the first midterm about like how they should feel about the final?
Yeah, you know, I thought about doing that and I decided against it just because this was kind of awful. And I saw some people who I think kind of know what they're doing, even though they had like a score in the 40s. And I've seen people with higher scores that I'm like concerned about that had like, you know, 50s or low 60s. Generally speaking, like the median is around the high 60s probably in all three sections. I mean, I counted some of the exams to come up with that, so I mean, it's probably in the high 60s. And you know, if you got like above a 75, then you're in good shape. Like amaze balls would be like 85 or above. You know, if you're in the 60s range, that's kind of the borderline area. You know, the sort of warning area would be like the very high 30s up through the 50s. And I would be most concerned if you had like below, like somewhere around 37, but again, there were a few people who got scores below that where I think they kind of knew what they were doing, but they didn't understand some of the concepts and they need to get those concepts down. I was most concerned for people that it did not seem they were able to write code. You know, there are a few students that don't know Java that are still in this course. I don't know how they got through Software 1. It makes me kind of angry because I want to be able to help them, and they need more help than I can provide in the semester. And also, students have to actually come see me for tutoring if they want me to help them. I can't, you know, magically like ejaculate information in your brains from a distance. That's probably a good thing for you. Honestly, yeah. You know, for the final, you want to make sure you know. So probably more than half the exam is going to be stuff since the second midterm. So we're talking recursive descent parsing up through all the random crap at the end. For most of the random crap at the end, it's conceptual stuff. Although you should be able to do some relevant stuff like tracing static code, tracing exception handling. You won't have to write JCF code or Java IO code or exception handling. You should be able to write the exception handling, but I won't ask you to. Or static code. Maybe you would have to write static code. You should be able to, like, use a static data member. But you should be able to trace static code. And no basic concepts related to all the stuff over the past couple weeks. But for the compiler stuff, you know, be able to write parsing code. Project 8 is definitely one to review. I mean, if I give you parse while, you should be able to write parse while. You should be able to write a new instruction if I give you the CFG. You should even be able to write parsing code for a different language if it's very simple and I give you the CFG for the language. If you have to write parsing code, which you will, there will be a CFG for you to follow. I mean, that's how you do it. You base it on the CFG. And the CFG will be written in such a way that you can take advantage of it. I won't ask you to write code generation code, but you should be able to do it by hand. And you should understand it. You won't be asked to write virtual machine code. You should know what a virtual machine is because you've been working with one ever since you started using Java, the Java virtual machine. And the rest of it is going to be like big overarching concepts that we've had throughout Software 1 and Software 2. So, like code correctness, design by contract, pointers and references, stuff that we've had questions on every exam in Software 1 and Software 2. You can expect to see again. Also, there will probably be a question, just like we had on midterm 1 and midterm 2, where we say, here's a convention and a correspondence and measure this. So they'll durable more than likely be like that. You had a question?
Yeah. Are we going to get tested specifically on the Java collections framework or just like IO stuff?
I mean, you'll get tested. Like, you should know concepts related to JCF. You won't have to write JCF code. You haven't had enough exposure to it. But you should know things like the fact that map, doesn't implement collection or iterable, right? And you have to work with a view that's backed by the map. Since it's backed by the map, I mean, you should know the limitations of iterators. And the fact that you can't change the map while you iterate over the view because they're backed by each other. So, I mean, that has the same limitation. You should know how to work with the components in a general sense. And you should be able to trace JCF code if you have to. It's not likely that'll come up. So definitely the concepts behind it. And make sure you know the flow of control of exceptions. You should know when an exception happens, like, what happens next. Which lines of code are going to run in what order. The fact that if an exception happens and it's checked, well, a catch block must run. Your code wouldn't compile if there wasn't a catch block that could catch a checked exception. The only exception to that is if main throws exception, which is retarded. You don't ever want to do that. But yeah, you should understand the basic concept of how it works and be able to trace exceptions in the code. That's most of the big stuff. Other questions about the final or the midterm, or any examples or more information that you need on stuff that we covered that you're rusty on or not sure about?
Are you going to have any more opportunities for office hours or anything?
Yeah, I don't have office hours next week. And it's a little busy, but I do have a lot of time that if you look at my schedule, you know, there are places I can meet. I've got a couple doctor's appointments on Tuesday that I can meet early in the morning and later in the evening. Also, there are other places on my schedule I can meet. So just look at my schedule, send me an email with a time you'd like to meet, and we'll arrange it. Might be good to go over your previous semester's exam if you took it with me, and or retaking the course, which happens. I'm not surprised by the fact that people retake the course. This is a hard course. I'm surprised by the fact that they retake it with me. Not because I'm terrible or something, but because the exams are open. I once had a student say that they were tempted to fail the final so they could retake the course because they liked me too much, and that's when I knew I was too good. I'm kidding. I'm not that great. That did actually happen. That's a true. Yes.
What do you think is the best way to look over the concepts?
It's a good question. If you took notes in class, you know, I would rely on that more than the slides, because the slides get into a lot of irrelevant stuff. But you know, the class slides are not bad to go over the basics. You know, for stuff we did labs on, reviewing the labs is useful. You won't have to write. You know, I wouldn't bother reviewing the code generation or virtual machine labs unless you really wanted like more practice with code generation or something. Those aren't going to be useful. But if you get the static lab from yesterday to work, you know, I would review that one. You know, I mean, you should be able to write static code and trace it. You should probably look over the exception handling code that you've written. But really, in that case, it's more theoretical. You really just need to know the order in which statements execute. So I mean, you can look this stuff up online too. Like, you don't have to rely on the class slides for stuff. If you want to know how exception handling works and the order in which things happen, you can look it up online. There's tons and tons of websites out there that describe it. Definitely review project date because the code is going to be relevant. And for general concepts, like, you know, review software 1, midterms and final, review software 2 midterms. Any more questions on final exam? I'm still taking questions, but I'm going to sit down because my experts are standing up for way too long. Any more questions? Raise your hand really high so I can see over this guy. There you go. Okay, if you have specific stuff, come up to me here. In case I didn't mention, the final exam is, it's not going to be this ass. Like, you'll have like maybe a little bit more material than midterm 1, but you'll have like twice as long to do it, so there will not be as much time pressure as there was on midterm